Alright, we have going to be an inducting situation. We have a rod here that's moving to the left, and we've got to figure out the magnitude and direction of the current. We're told that it moves left by 2 centimeters in 0.12 seconds. Okay, so there's a couple of different ways we could do this. We could say that the velocity is 0.02 meters per 0.12 seconds, right? So that's 0.167 meters per second. And then we can say that the induced EMF is BLV, right? We could use the motional EMF formula. So that would be 24 times the length of the rod, which is 8 centimeters, times the velocity, 0.167, and that results in 0.32 volts. Or we could say that the induced EMF has a magnitude of N delta phi B over delta T. Now N is 1, it's just a single turn loop. And delta phi B, in this case, is B delta A cosine theta, because it's the area that's changing. Okay, well, the area changes by, well, here's B. The area changes by 0.02 meters, or sorry, yeah, 0.02 meters, 2 centimeters by 8. So the area, this little change in area here, delta A, is 0.02 times 0.08, and then we multiply that by cosine theta, because obviously the area vector is perpendicular to the page, so it's in the same direction. At least it's parallel to the field. Okay, and then we divide that by the time, which is 0.12, so that's 0.0, let's see, what does that work out to be? 0.0384 divided by 0.12, and that's 0.32 volts. Okay, same thing we get up here with BLV. Okay, so anyway, no matter how you do it, the induced current is then the induced EMF divided by the resistance. The resistance is given to be 1.7 ohms. So that's 0.19 amps. There's the magnitude of the induced current. Now for the direction, we've got to do this little logical train where we say, well, the initial flux is into the page, and as this moves left, right, the number of x's is decreasing. Therefore, the induced field is going to try to replace the x's that are being lost. And the only way you get an induced field that's pointing into the page is if you have the current flowing around in a clockwise direction. So the induced current is 0.19 amps, and it's clockwise. There's your answer.